Okay, so we were considering which element was the one that we're going to be removing, right? So if we look at what it takes to remove each one of them, either the first, the last, or to pick an element to actually remove, then we notice that doing either the first or picking a particular element is going to take us more time. So let's say we were just trying to get some removal method, then removing the last one is the one that is going to do the trick, because for me to remove this, the only thing I need to do is to move my pointer from last. Yeah, we can make last equals last dot next, and it will be here, and this one will disappear as we saw, right? So that will be the best thing to do. Now the iterator, an iterator is a method that will allow me to visit each one of the elements of my collection, namely this collection. Okay, so if I want to visit each one of the elements, I will create an iterator. Okay, now let's ask, what kind of iterator do you want for your collection? Every collection needs to have an iterator. It needs to have a way to visit all of the elements for whatever the reason. You may need access, sequential access, or different kind of access, but you will need a way to get to all of the elements. Okay, so if I could access my first added element first, then I could do this, right? But if I mean the first added element first. So let's say that I want to print my list, or I want to use my iterator to go first to the first element that I added, then to the second element, then to the third, and so on, all the way to the last element. However, if I do this, it's going to mean that if I have first here, last here, and cursor here, what I am going to need to do is going to be move cursor all the way to the end and then print first. Then I have to go back and start again and go to one less than that. Okay? And then I'm going to go and do it again and start and go one less than that. Okay? And finally, I will print the last one. So that is definitely a no-no. It's more than O. It's a little bit less than O of n squared. It will be a logarithmic function if you're thinking big O. So what we're going to do is that we're not going to try to do that. Let's try the cheapest one, in time and effort. And if we're going to print it, we can print the last added element first, and then we just do one traversal only, which is really nice. Okay, this one we're going to just print, and then be done. Okay, so it will go basically, there is my one traversal O of n, and I'm out of there. So our interface so far is going to look like this. We have the add element, after the previous, I'm going to be adding after the previous elements on the list. We're going to have the remove element, which is going to just remove the last element added. Okay, that's the way it's going to look. And then we're going to have print elements, which is going to print the elements in the reverse order in which they were added to the list, meaning that the last element added is going to be the one printed first, just like with when I remove, I will remove the last element added. So this is kind of okay because we don't have a particular setting for this linked list. We are the bosses right now, and we're seeing how we want it. So now this suggests that we have these three methods. So let's take a look and let's ask ourselves, what is in a node? And I am thinking literally, what is in a node? Well, each node will have data. That's what it's going to have. Some data in there, some stuff, and we're going to be accessing it, right? Now, into 11, whatever the node has inside is really irrelevant, because the whole idea of data structures class is that you figure out how to better store and retrieve the information, that you have in a particular structure, how one structure is better than another, and not exactly what is inside. That is just an afterthought. So for convenience, we're going to just assume that there is an object inside the node, any object. Okay, so we can say, well, our nodes have objects just like with array lists, and you can think, well, if I ever needed to store some primitive data types, I can always use a wrapper class, right? And there it is, my data, and this is pointing to null. Okay, so let's try another collection because we already did one. So let's think of something that we have already done in the classroom and let's work with it as well. So in this one, we have a sorted list. Remember the sorted list that we worked during class? Now let's take a look at it, and let's take a look at the first interface that we designed. Let's look at this one and let's see how we can marry them. Okay? So in the sorted list interface, remember we have to add the element where it actually belongs. So to add the element, we're going to actually insert an element, and the idea is that the list that we have has to remain sorted at all times. If we add anything, if we remove anything, if we visit all the stuff every single second, everything has to be sorted. Okay? So remember what we said in class? We said, well, in the add element, first we're going to look if the element to add is smaller than the first element. That's just a constant, 1. If we speak big O, that's just a constant. The second one is the same, it's just a constant. We're going to look if the element to add is larger than the last. If that's the case, then we're going to save ourselves the traversal of the list. Okay, so we begin by saying that cursor, last, and first are all in our first node. Let's say we added the first node and it contains a number, the number 120. Perfect. Now, when we are adding the number, where we're going to look for that place where we need to insert it, remember what we said, do we accept duplicates or we don't? Well, let's say I want to add the number 14. I have not answered the question if we accept duplicates because that is up to you. Okay, you have to decide if your sorted list interface will accept duplicates and how you're going to deal with it. If you're accepting duplicates, is this duplicate of that first one going to be inserted before or after it? Those things, if you're going to accept duplicates, those are the little things, the little nuisances that you have to check out before you go on. Okay, so for example, here the number 14 is the one that I'm going to be adding. So I'm going to be adding number 14. So it's going to check and it's going to come and add it here. Now, as soon as I add my number 14, my cursor and my first are in here and last is over here. Cursor, I have it in here because it needs to move through the list whenever I need to find an element that I am going to be adding, right? So I need to watch out for that. Now let's say I want to add the number 34, as you can see it here. So my number 34 is going to come somewhere in there and cursor is going to find the spot. Once it finds the spot, then we have that. Once the new node is installed in there, then cursor needs to actually go back and stay with first. So it's going to be right there and wait to see what's going on. Okay? To wait until we decide that we want to actually add another element. So now, if we wanted to remove an element, which element do we want to remove? Now, this is a sorted list, so let's be a little bit more, it's going to be a little bit more complicated than the very first list that we made. So let's try to think what is that we're going to be doing. First, if I could remove the first one, so I will be removing this one. I could remove the last one, or I could remove any element that matches the data that I would be looking for. Okay, so I have those 3 options. If you think of any other option, you can just add it. So if I want to remove the first, I have to move both cursor and first to the next node. So that's the simplest one. If I'm going to remove the first, because I'm just going to do this. And once cursor and first move, this node is going to not have a reference. So it's when it doesn't have reference, it just goes away and the Java garbage collection man comes and picks it up. Okay? So what if then, if we want to remove the last, let's go back to the beginning. So if I want to remove the last, then I need to go all the way here and get rid of this, right? So I need to get rid of last. And for that, I'm going to move the cursor right before last. And then I am going to say, well, let's take, I can have a couple of different ways of doing this, okay? First, I can say if cursor.getNext equals null, then I will move, I know that I have found the item right before last. Another way that I can work this out is that I can say if cursor, when cursor dot get next equals last, because last is over here, then I know that I have reached the node right before last. Okay? Now once I have done that, then I can just go ahead and get last equal cursor. When that happens, this will disappear. Okay? So if I actually want to remove a particular element, that will coincide with this data, then I will need to iterate through the whole list, visiting each element. Okay? So do you remember what we said in class when we're going to be visiting each one of the elements? Let's see if you actually remember what is that we said. We said we needed a precursor. Okay, so if we need a precursor, wherever the cursor moves, the precursor will remain one step behind. The only time when it doesn't stay one step behind is when they are both at the very first element, because precursor cannot be here. Otherwise, it will just fall in the emptiness of null. Okay, so we're going to move and we're going to look first if we're going to remove the element. Because the list is sorted, we can actually ask a question. And we can look if the element to remove is smaller than the first one. If that's the case, then we can say, well, there is no such element, right? The next question, the logical one, is, well, let's see if the element that I want to remove is larger than the last one. And if that's the case again, then the element is not found. Those two questions are constants, and they are going to allow me, they're going to save me a whole traversal. Okay, just to figure out that the elements are not there. Any questions? Email them to me. So in this case, as we said, we definitely need the precursor. Now, what if I want to print all the elements from the smallest to the largest? Now that is going to be simple because the list is already sorted from the smallest to the largest, right? So it's going to print in reverse order in which they are added to the list, and we have added the smaller elements before the previous elements and the larger ones after the previous elements, which, in a way, it sounds like the first time when we were building the list, but in this case, the list is sorted. So it's going to be easy to print just from the last one that we printed all the way, the first. In regards, let me see, go back here. From here, we start here printing in first, and we're going to end up in last. Okay? Oh, there it is. So we start from here, and we move to the last. Okay? So with this, then we realize that we have our sorted list interface, which we have an add element, which contains the data. We have remove first, another method, remove last, remove the element, which is data, and we're going to print the elements. So that is what we have so far in regards to our sorted list. Now, in here is where comments actually play a very, very important role, because we're going to be using comments within the interface